Introducing the next generation structures range from TecQuipment. This new compact, robust range offers clearer demonstration of experiments building on the tried and tested TecQuipment modular technology. Compared to the previous structures range, it is also easier to set up and use and includes additional experiments. Stay with me on this video to watch as we look at this more closely and demonstrate a selection of the experiments within the range. The next generation structures range is suitable for teaching the basic principles of structural engineering, relevant to many specialisms of engineering from civil and aeronautical through to automotive and marine. There are 21 experiment modules within the next generation structures range. These are all purchased separately. There are experiments to teach basic structural principles relating to beams, bridges, cantilevers, arches, struts, davits, weights, reaction, moment, shear force and torsion. First, let's take a look at the hardware that lies at the core of the range, the structures platform, the STS1. Any of the 21 experiment modules can be attached to the solid and stable platform that allows easy viewing of the experiments from all angles. This makes it perfect for use by groups of students and for longer range viewing in classrooms or even for remote viewing via video link. The small footprint and low level structure also means that the frame takes up less space in storage. The beauty of this is its simplicity and stability. There are only 4 main parts: the 2 steel end panels with adjustable feet, supporting aluminium beams that run horizontally, and the USB interface hub. Speed of setup and the ability to get accurate results are critical. This is why the supporting aluminium beams have slots and clearly visible scales to allow you to fit parts of experiments easily and precisely. What I particularly like about this new range is the USB interface hub. It's compact and mounts on the frame. It takes the data from all the sensors on each experiment module, then converts them into a format that can be used on the data acquisition software installed on a nearby computer. No extra hardware is needed. Simply put, it's neat and tidy. Now let's talk about the software. Because each of the 21 experiments has different load cells, indicators and strain amplifier, the software has predefined setups for each individual piece of experimental apparatus. All 21 have various experiments that you can perform that can be selected individually from a drop-down list. The big improvement to the software for the next generation structures range is that it has been integrated into TecQuipment's main versatile data acquisition system, VDAS, which is available for unlimited free downloads from the TecQuipment website. As I've already mentioned, there are 21 different experiments. I've got 5 out of these to show you in this video. Firstly, the deflection of beams and cantilevers, the STS4 experiment that I'm setting up here. The focus here is about helping students understand the basic elastic properties of beams and cantilevers, elements that feature in most structures and in things like industrial cranes and large machines. Using the supplied beams, you can test their structural stiffness, deflection, and in particular, the elasticity of the beam material and composition, exploring concepts such as Young's modulus, the second moment of area, and Maxwell-Betty's reciprocal theorem. Now we're going to examine the bending stress in a beam experiment, the STS5. This studies the stress distribution across a beam. You fit the inverted T-section held by 2 supports like this, which for stability has an offset neutral axis. Strain gauges are attached at different heights up the beam to measure the strains due to the load. Then a load cell here measures the force applied at the midspan of the beam. For this experiment, I'm going to show you how the software works. With the hardware all connected and the software running, then you do the experiment clicking on the recorded button each time you log the data. You can now see the data in a table and export the results to Excel. Results can also be plotted on charts. Moving to the buckling of struts experiment, the STS12. Here you're able to teach students about Euler buckling loads, the relationship between strut length and collapse load, and the impact of using various end fixings. We've a setup here that looks at the use of pinned ends. The continuous and indeterminate beams experiment, the STS-13, is for the practical teaching and reaction and moments of different beam support arrangements. You can also learn about the principles of superposition, the effect of sinking support and influence lines. This is currently set up using a rigid heavy beam to examine statically determinate systems. By applying loads along the beam and then measuring the resulting reactions and deflections, you can calculate the moments. Lastly, we are now going to examine the torsion of circular sections experiment, the STS-6. Circular sections are used in structures and vehicles. These are generally resistant to axial loads, but can be subject to twisting loads. With this experiment, you can examine the relationship between specimen length, torque and angular deflection, and the practical theory of torsion, shear modulus, and the polar moment of inertia. By fitting these rods or tubes between the two chucks, you apply the twist with one chuck, connect to an angular sensor to measure the angle of deflection. Over here at the other end is a torque arm that applies the resultant force to a stiff load cell to measure the resulting applied force. The experiment comes with a range of rods and tubes of different materials, and the adjustability of the chucks along the supporting aluminium beams means that you can change the effective rod length as well. For more information about the next generation structures range, click on the links below. Don't forget to like and subscribe to the TecQuipment YouTube channel for the latest videos and live streamed events. Thank you for watching.